I get the opportunity to talk to you about toxins in our world, and at first I felt kind of put upon because this is a 4-hour lecture series that I give at Loma Linda, and I had 40 minutes until I heard Russ earlier say he had to condense 2 days into 40 minutes, and then I was like, well, I guess I can't complain. So, all right, let's move on. So we've spent today learning basically this, right? The definition of functional medicine from the Institute for Functional Medicine, that we ask how and why illness occurs and restore health by addressing the root causes of disease for each individual. And one of the early forefathers of functional medicine, Dr. David Jones, said this: disease is an imbalance. We have too much of the things that we don't need and not enough of the things that we do need. And from that has come the expression gets and rids. What do we need to get more of, and what do we need to get rid of? And that's really what we're going to be talking about. So this is the exposome. And if we think about the things in our environment, both the things from our outside world and the things from our internal biology and physiology, we can think about some of the negative pieces as being like irritants. They irritate our immune system. They may cause an immune response. That immune response may include the release of cytokines, like what happens when you get infected with the flu. And that massive release of cytokines makes you feel achy and tired and like you don't want to see anyone in the world ever again. So those cytokines are what starts that whole immune response. And that immune response can be short-limited, like it is with the flu, or it could be prolonged, like we heard about earlier with Dr. Long and Dr. Chirac, where you have this autoimmune inflammation or just immune inflammation of the brain that results in a process of dis-ease, right? Movement from having not enough of what we need and too much of what we don't need into this state of imbalance. When we're thinking about health, what are the things that improve our health? Well, we've talked about exercise, we've talked about stress reduction, we've talked about food and diet, we've talked about microbes, and now we're going to talk about toxins. When we think about the things, oh, thank you. Then I have to look like a granny. When we think about the things that are negatives, when we think about the things that are our positives, right? So we want to build those things up. If our health is like a bank account, then we want to be adding things into that bank account rather than taking too many withdrawals from that bank account. But now we're here, life in 2020, which feels weird to say, but that's where we are. And we've got things, we've got stress, we've got toxins, we've got microbial imbalances. And what is all around us? Take a deep breath. It's a really big one. Air, right? We breathe over 10,000 cubic feet of air a day. And what's in that air? Well, we know that it's oxygen, it's nitrogen, it's carbon dioxide, it's all of these things that we know is in there. But what about all the things that we try to forget are in there? The pollutants, the particulates, the things that we see on the horizon. How long can we go without air? Come on, you guys know this. How long can we go without air? About 3 minutes. Right? About 3 minutes, and then that oxygen deprivation has led us down the path of free radicals and cell destruction, and we can no longer survive. Then how about water? How long can we go without water? About 3 days. About 3 days, and then we no longer have enough water left in the systems to sustain life. And then how about food? How long can we go without food? About 3 weeks. So we've got 3 minutes, 3 days, 3 weeks, and then we no longer have enough in the account, in that health account, to sustain life. And those are the things that really we need to be thinking about when we're looking at where is our toxic burden coming from. Because people say to me all the time, "Oh, I don't have any toxic exposures. Like, I'm good. Like, I eat clean. I don't put all that stuff on my skin. I'm good." And I'm like, "Do you breathe? Do you drink water? Do you eat?" Then you have chemical exposures. So here's what we know about chemical exposure. So the global production of chemicals is rising at a rate of about 3% per year. And that means that from the index year of 2000 to 2024, we have a doubling of the chemical production, and that it will double again before the year 2050. And every year, about 2,000 new chemicals are registered for use in our everyday items, including our food, our personal care products, prescriptions, all of the above. And since the 1940s, we've had over 85,000 synthetic chemicals that have been registered with the US EPA. And that's based on the Toxic Substances Control Act that they have to be registered. About 3,000 of those are manufactured in high production volume, which means that over 1 million pounds of each one are produced and or imported into the United States every year. And then of the approximately 900 pesticide active ingredients that are registered with the EPA, more than 160 have been classified as known or suspected carcinogens. And yet, 350 of those have been approved to be ingredients in the food that we eat. So where do all of those chemicals go? Well, they go into the air, they go into the water, they go into our food, but they also end up in us. This is a study that was done by the Environmental Working Group. They looked at the cord blood, the umbilical cord blood of newborn babies, and they found that the average baby tested had more than 200 chemicals in their cord blood. So that's how we're starting life. Now, many of these chemicals are substances that can interfere with our hormone or endocrine system, and they're called endocrine disrupting chemicals, or EDCs. They can interfere with how a hormone is produced. They can increase the production, they can decrease the production, or they can block the action of that hormone. When they have a specific action, but they're not biologic, they're foreign to our biology, they're called a xenobiotic. Or in the example of BPA, where it has specific estrogen effects that we'll talk about in a minute, it's called a xenoestrogen. So that means that it's foreign to us, but it has a biological action. So we now know so much about this subject that in 2012, the World Health Organization published this white paper called The State of the Science on Endocrine Disrupting Chemicals. And it's a summary that is a mere 300 pages long. That was the summary 7 years ago. And these are not uncommon chemicals. These aren't rare things. These are things that we encounter all the time. Air pollutants, the BPA. Okay, so BPA, we all are familiar with this because now everything is labeled BPA free. So do you know what that means? That means it has BP alphabet soup, BPD, BPF, all of these other chemical substitutes, some of which have been shown to actually be more toxic than BPA. So BPA has an interesting history. It was originally developed as an estrogen mimicker. So it was meant to be a hormone replacement therapy for women. And in fact, early studies were done on hormone replacement in women. So we know that it has substantial estrogen effects. But we put it in all kinds of things that we handle and encounter every day. It's in plastics, as we know. It's also in those thermal cash register receipts that we all handle. And if you happen to have used lotion or hand sanitizer before handling that receipt, guess how much that increases your absorption? 200-fold. 200 times more BPA will be absorbed through your skin if you've used one of those things. Now, the safe estimates for BPA were based on studies of how our behavior was estimated, how it was thought that we would handle receipts, like that we would have 2 or 3 finger contact with a receipt for generally not more than 8 to 11 seconds. And then based on that, the estimates of safe exposure were created. And so when that's been studied, we find that that's not true at all, because what do you do if your hands are full and you have a receipt you need to hang on to pick up your takeout order? Yeah, you stick it in your mouth. Exactly. You stick it in your mouth where you probably have like 1,000 times more absorption. So we have accumulated far more BPA than was ever intended when this was allowed to be used. And then what about like flame retardants? Well, we put those in our kids' pajamas that they sleep in every night. And it's in every furniture foam and fabric that you have in your home. And what happens to that foam and fabric over time as we sit on it and our friends sit on it and our pets maybe sit on it? It breaks down, right, a little bit. And that becomes part of the dust in your home. And then that dust is what you're breathing and what you're swallowing. So I'm super happy to have this exciting and very positive talk to share with you today. It will get better. There is a happy ending. So then let's see what else I want to talk about. Well, we talked a bit about pesticides. Pesticides are used, as we know, on our food. They're used all over in golf courses, and all of our municipalities will typically use pesticides on the landscaping that's all around us in our parks where we may go, where our kids play. And then we have phthalates. Phthalates are also a plasticizer, but they happen to have a characteristic that allows them to volatilize things. And so it increases the volatilization of whatever else it's in the product with. So it's used in things like perfume or air freshener or all the cleaning aisle. When you walk into the grocery store and the cleaning aisle is like knock you on your you-know-what, the odor is so strong, that is phthalate central. Anything, a plug-in for an air freshener spray, you name it, all of those, if it says fragrance on it, you just need to translate that in your head from now on. That means phthalates. We know that these endocrine disrupting chemicals disrupt the signaling system, and we heard about that a little bit just a moment ago. And some of them are also called obesogens, and that means that mostly through this pathway called PPAR gamma, they increase both the size and number of the fat cells. So we have a saying that is, the solution to pollution is dilution. That's a functional medicine saying. And what that means is, as you accumulate toxins, they tend to be fat soluble, so they're stored in the fat. As you have a greater and greater load, what does your body need to do to keep that concentration from tilting that allostatic load that Dr. McCarthy talked about this morning? You need more fat to kind of compensate for what that is. So we have this whole mechanism for how many of these chemicals lead to more obesity and more of our obesity epidemic, including our diabetes epidemic. So these are the 2017 published statistics that 30 million people in the US have diabetes, so that's a little under 10% of our population. 84 million people have prediabetes. So what does that mean? What does prediabetes mean? It basically means that you have the metabolic derangement of diabetes, but you just haven't quite crossed the finish line where we call it diabetes. So your physiology, your vascular system, everything is equally messed up as if you had diabetes, but you don't get treatment. That's the concept of predisease. So 84 million have prediabetes, which means they have diabetes, just not at that finish line. So that means a total of 114 million people in this country are affected by this disease. That's a third of our population, 1/3 of our population. It's projected to increase by more than half again between 2015 and 2030. And if you think about the complications of diabetes, kidney failure, blindness, amputation, organ transplants, kidney transplants, the expense of diabetes is tremendous to our healthcare system. And that explosion will add to the bankruptcy of our country from that type of thing. So this is not, though, a one-way street. We have a diabetes reversal program that we run at our center. And I had, a couple of weeks ago, I saw in follow-up an 89-year-old patient who had been on 100 units of insulin a day. And if you're not familiar with insulin dosing, that's a huge amount of insulin. That is a lot of insulin. So he was on 100 units of insulin today, came in at 88 years old and wanted to reverse his diabetes. Let's do it. So by 8 weeks, following the food plan and all of the things that we did in the intensive lifestyle program, by 8 weeks, he no longer needed any insulin. His blood sugars were near normal in the low 100s, and he didn't need medication to maintain it anymore. And when I saw him a couple of weeks ago, he's now a year out from accomplishing that goal of reversing his diabetes, and he still has a normal hemoglobin A1C, the measure of blood sugar control, the measure of diabetes, and is on no diabetic meds. So it's never too late. It's not just the environmental chemicals that we have around us, but our industrial use of the naturally occurring heavy metals has also had a profound impact on our health. We know that lead causes neurologic disease, neurologic degeneration. It also affects intelligence scores in children. And mercury has very wide-reaching effects, particularly on oxidative stress, creating oxidative stress, particularly mitochondrial oxidative stress, and then also on vascular biology, and we'll look a little bit at that too, and cognitive functioning, which are all kind of key things that we want to keep. So the history of lead is really interesting, and I unfortunately don't really have time to go into it. It took us about 25 years longer to figure out that we shouldn't allow a lot of lead in our children than it did Australia. But in the 1960, we allowed a blood lead level of 60. That was considered okay. That was normal. Then when I was doing my medical training in the 80s, we dropped that down to 20 and then 15. And then in 1990, it was dropped again to 10. And then that 10 held for a very long time, 2 decades, until it was just dropped in 2012 to 5. So I caution you that not always the state of the science the best for health. And not always does the current evidence reflect what is really optimal for health. Now we're hoping that the CDC will drop it again, because we know even at levels of 2 that it affects intelligence scores in children. The other thing I wanted to mention is that the half-life of lead in the body is a really, really long time. You can see blood is just 25 days, soft tissue 40, but bone is 20 years. 20 years is the half-life. So that becomes particularly important in postmenopausal women who begin to liberalize their bone mineral content and start to release that lead into the blood and increase the exposure of the brain and the other tissues to lead. And I think that it's interesting. It's a correlation. It's not a causation, but it's very interesting that 2/3 of Alzheimer's patients are women. So how about mercury? So I mentioned that it's the most biologically dangerous of all of the heavy metals, and it has a wide range of effects. The oxidative stress, it can reduce our plasma, our blood antioxidant capacity by more than 50%. It creates direct inflammation, and it also can increase blood clotting. So all of those are going to contribute to our vascular effects, where we can see high blood pressure and heart attacks and coronary artery disease, plaque deposition. So mercury correlates with cardiovascular disease. We can see it as an immune trigger for autoimmunity, and we can actually measure that. We can measure antibodies to mercury. And we can see it in mitochondrial dysfunction, which has a wide array of expressions. And then we can also see it in increasing the rates of diabetes by inducing pancreatic beta cell, the cells within the pancreas that produce insulin, by increasing beta cell death and beta cell dysfunction. So the EPA has given us a recommended safe daily intake of this poison, and that is 0.1 micrograms per kilogram per day. So for the average weight person, that's going to be about 5 to 10 micrograms a day. So one silver dental filling releases between 3 and 17 micrograms of mercury a day, depending on the surface area. So a small one will release less. One that fills the whole inside of a molar or goes down the side is going to release more. And that release, daily release, is increased by rare things like heat and chewing and brushing. We don't do any of those things, right? So now you're taking something that's marginally at the threshold of your daily exposure for one filling, and you're increasing the release of that over the course of the day by your normal activities, and then you're multiplying that by the number of fillings that a person may have. It's not hard to imagine how we can rapidly accumulate quite a bit of mercury. So the high mercury fish, which is the other significant source of mercury. The high mercury fish, like swordfish, shark, king mackerel, and tilefish, those have about 60 to 100 micrograms of mercury in a single serving. That swordfish not looking so good on your plate now, huh? The moderate mercury fish, so albacore tuna, sushi tuna, a can of albacore tuna has about 30 micrograms of mercury. So that's why it's recommended that this be limited to not more than twice a week, because that'd be 60 micrograms. That brings you in at your approximate daily EPA limit. Lower are going to be light or skipjack tuna. That's going to be about 10 to 12 micrograms of mercury. And then the best is going to be your wild-caught Pacific salmon, very low in mercury typically, also typically naturally high in selenium, which helps to moderate the effect of mercury. So that usually has about half a microgram per ounce or less. So that bottom line is wild-caught salmon is your best bet. So our toxic exposure isn't just from chemicals, and it isn't just from other organisms that we're going to talk about here in a minute, because within our own biology, we produce a lot of toxins that the body has to process and get rid of. So we produce hypochlorite, for example, which, do you know what that is? It's bleach. We actually make bleach. We manufacture bleach. It's part of our defense mechanism in some of our white blood cells. We also produce hydrogen peroxide in peroxisomes that the white cells use to kill other organisms. We produce superoxide and other free radicals like we were just learning about in the last lecture. So toxic chemical or not, all of these things are things that our body has to process and manage for us. And then we also have to defend ourselves against the chemicals that are produced as defense mechanisms by all of the other organisms that we share our body with. And so we all know about mold. I'm sure that dorm refrigerators and apartment refrigerators are probably ripe with mold experimentation. I know it was when I was in college. So we're all familiar with that, and we're all familiar with penicillin. So penicillin, we know, came from the mold, the bread mold, the penicillium mold. So penicillin is a mycotoxin, which literally translates into mold poison. And as a mycotoxin, we were able to capitalize on its effect on killing bacteria, right? So it was a defense mechanism that mold uses to reduce the bacterial overgrowth in the local area so that it can have more resources for itself. But there are well over 300 mycotoxins that have been identified in the many, many different types of mold species that we can share our environment with. And we can really only test for a few. The interesting thing about mold toxins is that they don't affect us all the same. So mold toxins can affect some of us mildly or imperceptibly, or they can have profound effects on someone's physiology, resulting in this wide array of seemingly unrelated symptoms that can be vexing or frustrating for conventional medicine because they aren't a disease, right? They're basically a biologic poisoning on a low level, sometimes on a larger level, but typically on a low level. Not enough to come across as an acute poisoning, but enough to impact physiologic function and affect how the person feels. So mold can be very, very insidious. So we have the picture up here where the wall looks completely normal, but you pull that baseboard out and there's all kinds of mold behind that baseboard. Or the picture over here where the ceiling was removed in part of a shower. The shower looks otherwise normal. The wall looks normal. You don't see mold spots on it. But inside, behind the drywall, there's a whole community of mold living there. So we have to realize that these things aren't always obvious or apparent, and the way that they can be expressed in people as things that we end up calling fibromyalgia or chronic fatigue syndrome or things of that nature, where we're describing, like Dr. Chirac said earlier this morning, we're describing a constellation of symptoms that we're giving a name, but in doing that, we're really not identifying what set that ball in motion. And if we don't identify what set that ball in motion, then we have no capacity to help that person get well. So I want to share with you a case study. This is CB. Actually, she said I could use her name, but she was 68 when she came to see me. Strong family history of Alzheimer's disease in her grandfather, both of her parents, also in her sister. She was the primary caregiver for her mom, who had severe Alzheimer's, and she said that her mom was horrible and mean at that stage, and she did not want to end up like that herself. She had gotten to the point where she wasn't able to cook for her family. She couldn't follow a recipe. She'd take something out of the refrigerator and set it on the counter, and then she'd forget why she had taken it out. So she stopped cooking for the family. She was also withdrawing from people. Her primary care doc had just diagnosed her with probable Alzheimer's disease. And when we did her functional medicine timeline, that her life history, her health history over the course of her life, like Dr. Long and Schrock showed you this morning, what we found is that she had had multiple mold exposures. So living in Taiwan years ago, she had been present during a typhoon. There was a lot of mold after that. 10 years ago, she'd had a flood in her home. That mold had to be remediated, and so on. Most recently, she had moved into the area and noticed that her memory concerns had rapidly progressed since moving into the rental home that they were staying in, and they had no idea why. So we tested the mold toxins in her urine, and what you can see here is ochratoxin and roridin E. These are two different types of mold toxins. A normal exposure amount, because mold is all around us. We can't escape mold. We are not free of mold or mold toxins. But a normal amount of exposure should be down there at the low end, like 1.2-ish for ochratoxin, maybe less than 1 for roridin E. And you can see that her numbers of 6.51 and 9.64 were way, way up there. And then this is what I want to point out. So we have studies that have shown that ochratoxin can lead to significant oxidative damage in multiple regions of the brain. We also know that it can contribute to the development of neurodegenerative diseases like Alzheimer's and Parkinson's disease. And roridin E has the delightful history of having been used as a nerve agent in biological warfare. So these are very potent toxins. The trichothecenes, which word in E is, inhibit protein synthesis, and then they also are known to cause neurologic damage. So she had all of that swimming around in her, so we wanted to find out where was that coming from. So we did mold settle plates in the home, had petri dishes, leave them open for an hour, undisturbed, not walking in the room. So you're literally just seeing kind of what's settling out of the ambient air. And then you let that grow for a couple of days, and then you see what comes up. Well, down at the bottom, I have the reference range over here. You can see that 4 or less colonies is generally considered about a normal amount of household mold. And her Aspergillus level was at 6, and the penicillium was at 12. So those were very, very high counts. They decided to move out of the rental home. They purchased and moved into a new home. We retested the new home to make sure that that was a mold-safe environment for her, and you can see that these are now much more normal counts of ambient mold, and we have like one dominant colony and not a whole petri dish full of it. So after a year of treatment, we retested her urine mycotoxins at a different lab this time, so sorry for the change in the background. But what you can see here is that now the ochratoxin is no longer present and the trichothecenes are no longer present. Still a little bit of gliotoxin, but those predominant mycotoxins for her had been removed. Ultimately, it comes down to this, that we are what we eat, what we drink, what we breathe, what we touch, and what we cannot successfully eliminate. That's really what this comes down to. We're exposed to over 85,000 chemicals. Most of us are exposed to approximately 10,000 chemicals a day, which is a staggering number, but if you just think about pollution and what's in the air and everything that's around you. So we need to have a way of dealing with this. I don't know about you guys, but the first time I heard a lecture like this, I was like, man, I'm just like a soggy bag of toxins. And how do we get rid of them? How do we prevent it? How do we protect ourselves? And how do we get rid of it? So this is a schematic of the process of biotransformation, or what is kind of colloquially called detox. And the idea is this. All of our elimination pathways are water soluble. And toxins are typically fat soluble. They're lipid and they're non-polar. So we have to go through this first phase in the liver, which uses a system called our cytochrome P450 system. That's an enzymatic system, to change these toxins, to modify them enough that they become slightly polar. And then in phase 2, we can stick something onto them that makes them identifiable and water soluble, and now we can eliminate them through urine, bile, stool, or even sweat. In the middle over here, the intermediates are things like superoxide and all of these reactive oxygen species. And so we need antioxidants to help that phase. And then look at all the nutrients that we need just for phase 1 and phase 2. And this is shown in the liver, but to some extent, this is going on in every cell in the body, because every cell has waste that it has to be able to get rid of. And there's another wrinkle in this, because these are enzymatic systems. And enzymatic systems are determined by what? DNA. And DNA is subject to what? Mutation. So this is an example of one of the cytochrome P450 enzymes named 2D6. And this is showing us that between the people who are poor metabolizers, so 2D6 is responsible for about 30% of our drug metabolism. So it has a big job. So we've got the poor metabolizers on the one end and we have the ultra rapid metabolizers on the other end. And you can see by the number at the bottom that this varies by 1,000-fold. So there's 1,000-fold potential difference in our capacity to utilize the action of this enzyme. So what does that mean clinically? Well, that could mean the difference between someone who can't activate a commonly used pain medication into the form that gives you pain relief, all the way down to the ultra-rapid metabolizing mother who, say, has pain medication after her C-section and activates so much of that pain medication that her breast milk causes respiratory arrest in her infant. So no effect to death effect, one enzyme in this very complicated system. So now it starts to make sense why there's such a huge variation in how toxins affect us, that it's not going to be this thing X is a poison and this thing Y is not. It's going to be this thing X in this person with these other exposures, and this allostatic load is a poison. So now you see why you can't do one size fits all. And you can't do one size fits all studies on whether or not something is beneficial, because the background that sets up what that person needs is far more complicated than a single variable study. So, what can we do with our food? Every picture of food today has been full of an array of color. And that's because all of those colors represent different phytonutrients. And those phytonutrients were developed evolutionarily by those plants to defend against oxidation, to defend against UV radiation, to defend against insects. They all have a purpose. And so we can capitalize on the colors and what they can do in our bodies. So then the next question becomes, okay, so what I choose to eat is important. The color is important, but is eating organic really important? So yes, eating organic can have a profound impact on your overall chemical exposure. And the Dirty Dozen was mentioned earlier. If you don't already know about this, the Environmental Working Group puts out a list every year of the 12 most pesticide-contaminated foods, 12 most pesticide-contaminated fruits and vegetables, and then the 15 that are the cleanest. So if you're watching your budget, then you can focus on buying organic for the things that are on the Dirty Dozen, and the things that are on the Clean 15 you can safely consume as conventionally grown produce. So, what you choose matters, and we talked a bit about the plant colors, and that the colors have different, not only nutrient contents, but different phytochemicals. When we're looking at this, in the middle there, the green and the white, the crucifer vegetables, these are the ones that are going to increase our detoxification capacity the most. So broccoli, kale, cauliflower, Brussels sprouts, these are all going to have the most significant impact on increasing glutathione, and glutathione is our master antioxidant. And so by focusing on having those foods in your diet among your other colors, you can have a significant impact on your detox capacity. So the rainbow and the crucifers. All right, ladies, here's where the rubber hits the road for us. So, the average woman puts on 168 chemicals a day. And I know you're sitting there thinking, no, I do not do that. So just think about it. Think about the ingredient label on your shampoo, on your conditioner, on your body wash or your soap, on your makeup and all the different makeup that you're putting on your body lotion. All of those ingredients many of those ingredients are chemicals. So reducing our exposure from what we put on our bodies is another substantial way that we can affect our daily exposure rate. So there are about 13,000 chemicals that are used in cosmetics. About 10% have been studied for safety. So we have a chemical plan in this country where we have to prove that something is unsafe rather than prove that it is safe. So proving that something is safe is much more difficult, and so that's a metric that we've decided not to use. That's called the precautionary principle. So guys, you are not off the hook either. So you get about 85 chemicals a day. That's going to be your shampoo, you got your deodorant, your toothpaste, shaving supplies, it's in there. And teens are even worse because they use about 17 personal care products a day, so they have significantly more chemical exposure. So in the end, when we're looking at and thinking about creating health in ourselves, in our patients, in our family members, we have to take all of these things into consideration. What's going on in our external environment, what's going on in our internal environment, and then managing our ability to detoxify. And now, I hope with that knowledge that you all will be able to contribute to the future of our health. Thank you.